Pressure as a unit can be hard to get a feel for. We talk about kilopascals or psi, but unlike meters or pounds, those aren't units we can easily see. But there is a way. As any diver will tell you, water exerts a lot of pressure. You add almost 100 kilopascals, or the equivalent of 1 atmosphere, for every 10 meter depth. As it happens, our house is roughly 10 meters tall. If I string a tube to the ceiling of our 3rd floor, then pressurize the bottom to 1 atmosphere, the water will just reach that 10 meter mark. Now that we have that as a reference, we can open the valve at the bottom, start draining the pressure, and visually see what different pressures look like. Right at the top, we're just above 10 meters of water, or 1 atmosphere of pressure. That's roughly the average pressure at sea level on Earth, or in long-duration space environments, like the International Space Station. Falling to 8.5 meters, now we're at 85% of that sea level pressure. This is how the lighter atmosphere feels up in the mountains, when you visit Banff in Canada, for instance, or catch a FIFA game in Mexico City. The air feels a bit thinner, but still comfortable. This is also the lowest pressure observed in a hurricane or a tornado. Looping back to comfort, at 7.5 meters, we hit the minimum pressure inside an airplane cabin in flight. As a fun note, most phones have an accurate pressure sensor, and it's neat to see in real time how the pressure in the cabin changes as you go up and down. 1.5 meters further down, and we're at just 60% of atmospheric pressure. This is the limit of human comfort. You'll see this in the highest cities on Earth, like La Paz in Bolivia, or the South Pole Station, which, in addition to being extremely cold, also sits on almost 3 kilometers of ice. Now jump down to 3.3 meters, or about 1/3 of atmospheric pressure. This is how it feels to stand on the top of Mount Everest, almost 9 kilometers above sea level. Interestingly, this is also the pressure inside spacesuits. They can't inflate those to the full 1 atmospheric pressure because the joints would be too stiff to move. The partial pressure is more comfortable than is on Everest though, because the suit is filled with 100% oxygen, rather than 21% oxygen here on Earth, though that also leads to complications, such as having to pre-breathe oxygen for hours before donning the suit. Finally, at 2 meters or about 20% of atmospheric pressure, you pass out from lack of oxygen. This is what it feels like outside the airplane at that cruising altitude. Half that, and at just 1 meter or 10% atmospheric pressure, water starts to boil off at room temperature. And finally, way down here at 6 centimeters is the atmospheric pressure on Mars, which is less than 1% as it is on Earth. And that's what pressure looks like. I could do the same for the higher pressures, but I'd need a much bigger house. The pressure on Saturn's moon of Titan, for instance, is 1.5 atmospheres, while the pressure on a car tire is almost 3 atmospheres. It's important to find ways to visualize the units and numbers we work with. Good communication tells a story, and having similar mental images and understanding for abstract concepts gets us to the same happily ever after conclusions. Because the better we are at sharing those visualizations up front, the less pressure we feel explaining the technical stuff.